In this question, we have a broadband internet supplier that's guaranteeing a telephone line with an SNR of 24 decibels. So that's a minimum signal-to-noise ratio. So they're guaranteeing the quality of the telephone line. The question is, what's the maximum noise power as a fraction of the received signal power? So they want not S over N, they want N over S. The question is asking for the noise power as a fraction of the signal power. So remember the definition of SNR is 10 log to the base 10 S over N. And what we're asking for is N over S, so that's 1 over S over N. So we just need to reverse this equation. So let's put in the number. We've got 24 equals 10 log 10 S over N. We can divide both sides by 10. And then, because what we want is that, we take the anti-log, or 10 to the power of both sides. So S over N equals 10 to the power of 2.4, which is 250. Now the question is asking for N over S. So N over S is simply 1 over that. So the noise power as a fraction of the received signal power is 1 over 250. Now in part B, the telephone line is upgraded. It's improved. The quality is improved to 60 decibels. So now we have either an amplified signal or a reduced noise, but the ratio between the signal power and the noise power has been improved to 60 decibels. So the question is, what is the new noise to signal power? So it should be a smaller fraction than 1 over 250. So we can simply change the numbers. So let me simply replace the 24 with 60. So 10 to the power 6, we'll just leave it at 10 to the power 6. And N over S is 1 over 10 to the power 6, or we could write it as 10 to the minus 6. So that's the new noise to signal ratio. So clearly we have much less noise by that improvement in SNR. It then asks, what's the practical advantage of such an upgrade? So presumably someone is paying for this upgrade. So what does the customer get for their money? What is the practical advantage of having less noise? So when you have less noise on a communication channel, it means it's a clearer signal. So that's a better quality. So it's a less noisy line. But that's not what the question's asking for. It's asking for the practical advantage. The practical advantage of the upgrade is a higher data rate. In other words, faster communication. So their internet, their broadband, will be faster because the maximum data rate is proportional to the bandwidth available and the signal-to-noise ratio. So this is the channel capacity. We haven't looked at the mathematics of this yet, but we've mentioned how the signal-to-noise ratio will impact the maximum data rate. So the practical advantage of such an upgrade is a higher data rate, faster communication.